Okay, now computer network architecture. So when we talk about the architecture, it is a design in which all computers in a computer network are organized. An architecture defines how the computer should get connected to get the maximum advantage of a computer network, such as the better response time, security, scalability, etc. So the two most popular computer architectures are point-to-point and client-server architectures, and also collaborative computing. Now, when we talk about P2P, that means peer to peer. Now, in this peer to peer architecture, all the computers in a computer networks are connected with every computer in the network, and every computer in the network use the same resources as other computers, and there is no central computer that act as a server. Rather, all computers act as a server for the data that is stored in them. So this is what in Windows we say work group. We have already seen Microsoft servers, and in that we see two type of networkings. We have work group and domain. So it is also called work group and also called peer-to-peer network, where all the machines are administrator and all the machines are act as a server and client both at the same time. That means if you are having a file store in one machine, so it can share the file as a server and it can use the file from other machine as a client. So both machines, every machine in a computer network, peer-to-peer network, act as a server and client both at the same time. So we call them peer-to-peer network, or in Windows network it is called work group. Then the other next is what client server architecture. Now in this client server architecture, a central computer act as a hub and server. All the requests from client computers and all the shared data is stored in the server computer, which is shared with the client computer when a request is made by the client computer. All the communication takes place through the server computer. For example, if a client computer wants to share the data with other client computer, then it has to send the data to server first, and then the server will send the data to other computers or other clients. That means in this you have one server. In Windows we call it domain, where we have a server controller, which where we have a domain controller, which is a server machine, and all the other machine act as a client. All the other nodes act as a client. So they will consider in a same network, but will be controlled by the server. And all the files which we need, all the data which we need, all the software which we need, they are stored in this server and they are shared with these clients. So whenever they need them, they can access from the server. That is called client server architecture. Then we have collaborative computing. This is the new way of computer networking, and that is what it is. It is called a new model of computer collaborating computings. It is also called cooperating processing. It is becoming an important trend, and collaborative computing is a synergetic type of distributed computing where networked computers actually share processing abilities, and instead of simply communicating data between computers, collaborative computing uses two or more computers to accomplish the same processing task. It is actually a cluster. In Windows Server and in any other environment also, we called it clusters, where multiple machines comes together to do a single task. A single task, that means if suppose there is an application like web service, we are having a web service and we want to control run the web service, so we can't depend on one server. So we can do what, we can use more than one servers, combine them together, and they will work as a single server and they will handle that web service together. So that is also called what? Clustering. Now this is what the architecture of computer network. Now the types of network. If we say types of network, then we have these types of networks. We have these 5 types of networks. A computer network is a group of computers connected with each other through a transmission medium such as cable and wire. Now, communication network can be a following 5 types based on area and ownership. Now, give me a break. Just a minute. Just a minute. There are someone is playing something, so they will pass. Okay. Some rally is going on. Just a minute. They will pass. They are making noise. Samuel is still not able to join. Okay. So communication network can be a following 5 types based on a area and ownership. Remember, these types are based on area and ownership. So first is what? PAN, that is personal area network, then LAN, that is local area network, then campus, that is campus, that is a CAN, that is campus area network, metropolitan area network, and wide area network. Now first one is what? Campus personal area network. The personal area network PAN is a computer network for interconnecting devices centered on an individual person's workspace. Personal workspace, that means within a small range, within a range of your hand. So if you spread your hand, both the hands, then how long your network, how long your reach is there, within that range you can say it's my PAN network. Now a PAN provides data transmission among devices such as computers, smartphones, tablets, and personal digital assistants. Now PANs can be used for communication among the personal devices themselves, or for connecting to a higher level network and the internet, where one master device takes up the role as a gateway. A PAN may be wireless or carried over wired interface such as USB. So this, like this, for example, you can connect two machines together, or your mobile to your device, to your computer, your headphones, mouse, or printer which is on the desk, which you connect together. That can be called as a PAN network. Also, if suppose you are having a small room where you are having a wireless network, with that you are connected all the other devices which you are having there, that can also be called as a PAN. Then comes the LAN. Now LAN means local area network. Now local area network is a group of computers connected with each other in a small places such as a school, hospital, apartment, etc. Now LAN is a secure because there is no outside connection with the local area network. Thus the data which is shared is safe on the local network, area network, and can't be accessed outside. This is because it is only available for the local area. Now LAN, due to their small size or considerably faster, their speed can range anywhere from 100 Mbps to 1000 Mbps. I think the writing mistake, 10 Mbps to 100 Mbps. Now LANs are not limited to wire connection. There is a new evolution to LANs that allows local area network to work on a wireless connection. So if you are having a small office or apartment or hospital, we can say, or we can say multiple floors, like 2 3 floors building, apartment, or a hospital, or even a small school, when you spread the network there and you connect all your devices together with there, then you can say that is what a LAN. Now LAN means what? It is local area network. It is ranges up to 50 meters, we can say 50 to 100 meters. So within that range, if you spread the network, it is all called LAN. Even a small room you are having with the wireless network, it is can also be called as a LAN. So PAN is very small. LAN is more. It is a we can say bigger than the PAN, but not that bigger. Like if you're having a building where you are having 3 floors, so you can have LAN on first floor, second floor another LAN, third floor another LAN, or maybe you can say on the all the 3 floors you can have a single LAN. Now remember I said because of the ownership, so these type of networks are divided in ownership. That means if you're having a LAN on first floor and another floor is by owned by someone else, then the first floor is separate LAN and the second floor will be called as a separate LAN. If all the floors are owned by single authority, then we can say that this is a single LAN. Other than that, it is considered as a different LAN. Hmm. Welcome, Josh. You were trying on SM OAS. Okay, disable your mic. Now, what we are doing, Joshua, is just refreshing your memories about the networking. So, we are starting CCNA ICND1, which is the next level of networking which we have already done. So, for that, we have to just refresh our memories about networking. So, what kind of networkings we are having? So, the LAN is what? Little bigger than the PAN. It can ranges up to 50 to 100 meters, and it is called LAN, local area network. It can ranges on 1 floors or 2 3 floors or even in a whole building. Or we can say if you are having multiple buildings like 2 3 buildings, then also we can say there are LAN because it is ranges up to 50 to 100 meters. But if you are having multiple buildings together, then we can say it's a campus. So we can also say a campus area network, which is also called CAN. Now by mistake I think I have written here M, but it is N. Okay, I will correct that. So campus area network is larger than the local area network LAN since it may span multiple buildings within a specific area. Now most CANs are comprised of several LANs connected via switches and routers that combine to create a single network, and they operate similar to LAN, and in that user with access to the network, wired or wireless, can communicate directly with other systems within the network. So we can say like this is one LAN in the first building, other building is another LAN, or the other buildings are the other LANs, and we combine them together and we can say this is what campus area network. So it can be it is what larger than the LAN, but still the behavior of the CAN is same as LAN. Now why? Because these all buildings, these all things, these all place, these are owned by single owner. That is why we say this is what CAN, because it is owned by a single authority, single owner. Maybe suppose you see the university, so in your university when you go to the campus of university, you will see different buildings like libraries there, schools are there, some different buildings are there, laboratories are there, and they are in different buildings. So when you spread the network there, it is just little bigger than the LAN, so we can consider that as a CAN, but the whole characteristic of the network is like LAN, so we can say that it's also a LAN. Now the next one is MAN, that is Metropolitan Area Network. Now this network covers larger area by connection LANs to a larger network of computers. And in a metropolitan area network, various local area networks are connected with each other through telephone lines. The size of the metropolitan area networks is larger than the LANs and is smaller than WANs. A MANs covers a larger area of a city or town. It can ranges up to 1 kilometer to 100 kilometers. It can ranges up to like that. Now MAN is also type of LAN, we can say, because it is a combination of different areas of LAN, and with that it will be considered as a MAN because it's a range. The range of the MAN is very big, so bigger than the LAN and CAN. It is called metropolitan area network. That means it can cover a whole city. So within 100 kilometer or within a 10 to 100 kilometer, you can say it's a whole city is covered. Now why we say it is a MAN? Because it is owned and proprietary by the single owner. Now you can assume it like a mobile network. Mostly the mobile companies like Airtel, we have MTN, we have, they are covered their network all over the city and even all over the countries also. Now they spread the network and they called it like we can say that is the MAN network. Mostly these MAN networks are separately, we can say, in a area, a specific area, it is managed and controlled by some local authorities, and centrally it is managed by the central authority, but the ownership is same, so we say it is a MAN network, but still it is less than WAN. So we can consider this MAN as a small LANs which is combined together and is spreaded into the whole city. Now the last one is what? WAN. Now when we talk about WAN, that means wide area network. It provides the long distance transmission of data. The size of WAN is larger than LAN and MAN, and WAN can cover country and continent or even a whole world. So it is no limit here. An internet connection is an example of WAN. Remember, we can say internet is an example of WAN, but it is not a it is not, it is also a type of WAN. But internet is what? It's a public WAN. When we talk about WAN, that means it's a private WAN. So there is two type of WAN, we can say, public or private. Where public WAN is, we can say, it is an internet. Private WAN, then WAN is called when we have a company and they spread their own network all over the world, from one country to other country, from one continent to other continent. So it is called, it is also called WAN, but it is the private WAN because the owner of that network is a single company. For example, suppose Cisco or Microsoft, Apple, they're having offices in all over the world, and branches in all over the world. So they connect those branches or those offices together. So they used what? WAN connection. They use their WAN and their own WAN. They don't use internet. Internet is private, public WAN. Public WAN, that means it is also a WAN, but everyone can connect and everyone can use. That means if company tries to send some secure data, so it can be exploited by anyone in the internet. So they don't want that. They want dedicated line, so they use what? WAN connection, private WAN. How they use it? So there are cables spread all over the world, and which is managed by the international ISPs. So those give those lines on lease. So these companies purchase those lines on lease and they get the line on lease. They call it lease line for WAN connection. So they have to pay for that, and it is very expensive than internet. Internet, we are having internet which is less expensive but not reliable, not secure, but still we can have internet everywhere. But because it is not reliable, not secure, these companies use what? Private WAN. So when they get it from the ISP, so they get the response, they get the assurance like they will always get these lines available, and also these are reliable. That means only those people can use it, no other people can use that line. And other examples are like mobile broadband connections such as 3G 4G. So these are also what are connections of WAN. So those service providers, those ISPs give you those lines through these mobile, through 3G or 4G broadband also. So broadband connections are what the cable connections, and also when you get it from mobile and computer line, you will get 3G 4G and all that. So these are what we have seen, the type of networks, and that is also we have seen it, we have already seen these things in networking. But because these things are important, we are seeing it again. So because this is very important, so we are seeing it again. So next thing is what? Topology. Is anyone having a doubt about this, what we have seen? Yes. So this is the topic we have for ICND 1, as you can see. Basic networking concept. So after the type of networks, we talk about topologies. Network topology. Now network topology is the description of the arrangement of nodes, example switches and routers, and connection in a network often represents a graph. So no matter how identical two organizations are, no two networks are exactly alike. So however, many organizations are relying on well established network topology models. Network topologies outline how devices are connected together physically, and how data is transmitted from one node to another is logically. Now when we talk about topology, so there are two ways of describing it: physical and logical. Physical topology details how devices are physically connected. That means how they are physically connected to each other. Logical and physical topologies can both be represented as visual diagrams. Then, logical network topology is a conceptual representation of how devices operate at particular layers of abstraction. That means it defines how they work and how they send data to each other. So logical is how they work, and physical how they connect. And these are the topologies we are having. So there are 7 types of topology in computer networks. The first one is bus topology, then ring, then token ring, mesh topology, star topology, hybrid topology, and tree topology. Now these all topologies are not used nowadays. Some of them are old, not useful in LAN network, so they are not used. But the topology which we use is still these topology. The topology which we use actually, it is the advanced topology of these old topologies. So for understanding, for better understanding the topology which we are using right now, you should understand the topology of these old topologies also. So the first one is what? Bus topology. Now the bus topology consists of one continuous length of cable. It is called trunk. This one, as you can see the image, this is the one which is continuously connected cable, and it is also called trunk, and that is shared by all the nodes in the network. And a terminating resistor, that is called terminator, at each end that observes the signal when it reaches the end of the line. And these are the terminators on both the lines, you see, both the ends. So when the power goes there, then it will absorb the power and terminate the power. Now why I'm saying power? Because these cables are what? Copper cables. So the signal goes on these cables are on electric. That means the signal goes on these cables are electric signals. So when the signal comes to this end, this terminator will terminate the signal there so that it will not bounce back. Now without a terminator, the electrical signal would reach the end of the copper wire and bounce back, so causing errors on the network. Now data communication message travels along the bus in both direction until it is picked up by the workstation on a or a server NIC. And if the message is missed or not recognized, it reaches the end of the cabling and disappears at a terminator. And bus network topology requires a multi-point connection, and all nodes on the bus topology have equal access to the trunk, and this is accomplished using short drop cables or direct T connectors. And the numbers of the devices and the length of the trunk can be easily explained, and it use carrier sense multiple access collision detect technique to communication. So you can see this is the main cable and all the devices connected to the cable directly by using the T connector. T connector is like this, or we can say the drop line. And this main cable is also called the backbone cable. Now when the one machine sends the data, now all the machines have equal access on this cable. So one machine sends the data, so it will go to everywhere, in this side, that side, everywhere, and all the machines in the cable will get the data. And if the data is for that machine, then it will accept, otherwise it will do what? It will reject the data. So if the data is belong to someone, then they will accept or they will reject the data. And if the data is not accepted by anyone, those data will go on to reach the terminator either end, and then it will drop by the terminator. Now for this, it uses this carrier sense multiple access collision detect technique to communication. Now this is the technique which this topology uses. Carrier sense multiple access. That means if any machine wants to send the data, it will first sense the cable that whether any other data communication is happening or not. So if any machine sending a data on the wire, that means it will occupy the whole cable. That means the other machine will not able to send anything. If the same time two machines send the data, then it can corrupt the data. So what the machine do? First it will sense the cable that whether the cable is empty or not. Now if the cable is empty, then this machine will send the data. Otherwise it will do what? It will wait for some time. It will put a random timer in a second, and it will wait for that timer to expire, like it sets 5, so 5 4 3 2 1 0. Then again it will try, and if the cable is still occupied, then again it will wait, and it will again try after the timer expire. Now when the cable is empty, then it will send its data to the other machine. This is called carrier sense multiple access. But this is also not a foolproof communication system, because it can make a problem. Because suppose sometime two or three machines sense the cable at the same time when there was no communication, then what happened? All the three or four machines feels like they are not having any data on the cable, and they can ready to send. Now what happened? They will all send the data on the cable at the same time, and when this happens, it will collide on the cable, and they will find the collision. That means their data will collide to each other. Now when this thing happens, then what? They can detect the collision, CD. So this means what? They can detect the collision. And detecting the collision, that means when they would detect the collision, they send the jam signal. Now jam signal reaches to every machine, and they will do what? The all machine will wait. They will stop every communication, whether they want to send any or not. They will stop everything, and the all machines will set a timer for their machine. So after their timer expires, they will try to sense the cable and try to send the data. Otherwise, they will not do anything. So this is how they try to avoid the collision. And this is how they try to send the data by using CSMA and CD for collision. If the collision happens, then CD works, and if the collision they don't want to have a collision, so they use CSMA, carrier sense multiple access. So this topology is the old one. Now nobody uses this one. Why? Because it is having an advantage and disadvantage, but it is very slow. First thing, advantages is like it is cost effective, very easy to set up, no extra devices required, very less requirement for setup this bus topology. Cable required is least compared to other network topologies. That means we don't need much devices, we don't need much cable. Used in small networks, this is good for a small network, because as you increase the devices, that means the chances of collision is also increased. And it is easy to understand also, very simple to understand, easy to explain, easy to expand, joining two cables together. That means you can expand it easily. That means if it is 10 meters, then you can also add more 10 meters easily. You just have to join the main cable, extra cable into the main cable. So it is very easy to set up, easy to configure, easy to manage, cost effective. But these are the disadvantages, which is more than advantage. Cable fails, then whole network fails. If the main cable, the backbone cable fails, then your network will break. Then if network traffic is heavy or nodes are more, than performance of the network decreases. So if you're having more nodes which is generating more traffics, and it is getting heavy, then your performance will decrease. And cable has a limited length. Now when you try to extend the cable, these cables have limits, so you have to join more cables, but still they are having some limits. And this is the main problem, that it is slower than the other topologies. All the other topologies, not only the ring topology, it is slower than all the other topologies. Now because it is a old topology, so in old days they don't care about speed. The data was not that big. The data was only in kbs, in even in bytes, so there was no problem. But when the network when the data is advanced, when the things are getting advanced, data is getting bigger and bigger and bigger. Now we are having data in gbs, and speed is getting more advanced. Now we need more speed. So as the network grow, user wants more speed. So these user want more speed and speed and speed, and then this topology is not able to cope with that, and then because it is very slow. Now why it is getting slow? Because of collisions. If you remember what I said, every time when you face a collision, everyone has to stop. Everyone, that means whether you're having 10 machine or 100 machine, everyone has to stop and stop for some time. Now if you are having 10 machine, then it is okay, but when you are having 100 or 200 machines, then it is very difficult, because collision after collision, collision after collision, you have to stop and stop and stop, and then what, it gets very slow. Whether your cable is having a speed of 100 mbps, but still you may get less than 1 mbps speed, because it is getting very slow. Now because of that problem, we introduced with the ring topology. Now ring topology is totally it is totally designed to avoid the collision. This ring topology is what? A circular loop of point to point links. Now each device connects directly to the ring or indirectly through an interface device or drop cable. Now messages travel around the ring from node to node in a very organized manner, and each workstation checks the message for a matching destination address. If the address doesn't match, the node simply regenerate the message and send it to its way. If the addresses matches, the nodes accept the message and sends a reply to the originating sender. So all the devices are connected together with this ring, and the data goes like clockwise. So is either it is like this, or maybe we are having a device here, central device, where all the devices are connected together, and inside the device we are having a ring. Now data goes like from one unit, one node to another node. Like if you want to send data from this server, this unit to this, that means this node to this node, so the data will go first to this node. It will check whether whether the data is for this or not, and if it is not for this node, then it will send it to other, and if it is not for this one, then it will send it to other, and if the data is for this one, then it will accept. So this is how like it is goes like clockwise from one device to other device, and every device checks that whether the data is belong to that device or not. Now what is the benefit here? There is no chance of collision here, because all the data are going one after other. So there is no chance, there is zero chance of collision one data to other. So because it is designed to avoid the collision, but still it is having a problem. Now advantage of this topology is what? Transmitting network is not affected by high traffic or by adding more nodes, as only the nodes having token can transmit the data. So it does not matter how much devices you connect with this, or how much heavy load you are having, because they are not sending at the same time. So it will not affect. Now cheap to install and expand. This is also cheap to install like bus. We can easily configure, we can easily install, and also we can easily expand. We can add more devices in a ring. But you can see the disadvantages are bigger than the advantages. Troubleshooting is difficult in the ring topology. You don't know where the data is stopping. If you are having 50 machines connected to the ring, and you are sending the data from one machine to other machine, and it is going through 20 or 30 machines in between, so it is difficult for you to find out the problem, like which machine is doing the problem. Then adding or deleting the computers disturb the network activity, and that means what? If you are adding some machine here in between this link, that means you have to break the link, and when you break the link, you are breaking the whole network, and failure of one computer disturb the whole network. And just like you are adding or removing the computer, it breaks the network. If suppose the machine is corrupt, or shut down, then again it breaks the network. So if you are sending the data from this device to this device and this machine is not working, that means your data will not reach there and it will break the ring. So another way of this topology is token ring topology. So there is another ring topology which is called token ring topology. Here token ring network is local area network. It is in local area network which all computers are connected in a ring or star topology. Star, we will see what is a star, and pass one or more logical tokens from host to host. Now only a host that holds a token can send data, and tokens are released when recipient of data is confirmed. Now token ring networks prevent data packets from colliding on the network segments because data can only be sent. Only host that holds the token can send the data, and take tokens are released when the recipient data is confirmed. Token ring networks prevent data from colliding because the network segment can only send a token sent by the token holder, and the number of tokens available is controlled. That means how many students are there in the class. So this token ring is what? It is like a ring, but in the ring there is a token there, digital token, and data can only be sent by the machine who is having the token. So it is also avoid the collusion. That means if this machine is want to send the data, so it will have a token and it will send the data with the token. So if the token is not free, then other machines are not able to send the data. So other machines have to wait unless that token will be available, and we can manage we can control how many tokens are there in the ring. This is what the logical design, but the physical design is like this, where you are having MAU, like it is called multi-station access unit, is a special type of hub designed for token ring network. An MAU connects token ring station physically in a star topology while still maintaining a ring structure logically. So basically it is a device. In the device you are having what? A ring, and when you want to connect the nodes in that, you will connect with the cable in that, like this, and inside the device, MAU device, it's a ring. Now it can be also called what? A star topology, where we will see next what is a star topology. So it is also called star topology, where you have multiple devices. MU devices is for multiple computers to connect. So it can look like a physically it can look like a star topology, but basically logically it is still working as a token ring topology. So there is a difference for star and logical and physical. Now because the star token ring, the ring topology still have a problem of troubleshooting and breaking the ring, then we come up with this mesh topology. Now in the mesh topology, each nodes each nodes are what? Each nodes connected to each other. So So in mesh topology, each node is connected to every other node in the network. That is, each node has a dedicated point-to-point link to every other node, just like you see in the image. Now dedicated means the link carries the traffic only between two devices it connects. So each devices are connected directly to other device, and if this device wants to connect to this send the data to other device, it has a separate link for it. And in this way there exist multiple paths between two nodes of the network. In case of failure of one path, the other one can be used. So you can say like multiple paths are there for every device to connect. So and they are also connected directly each other. That means this is the topology is which is fastest than any other topology in all the topologies. And it is not having any collusion. It is not using CSMA/CD technology, because there is no chance of collusion. Ring also not use that CSMA/CD, because there is no chance of collusion. There is no chance of failure, lost data, because everyone is connected directly to each other. But it is also having a problem. Advantages are each connection can carry its own data load. So if you are having multiple machines, no problem, it is robust, fault is diagnosed easily, and provides security for and privacy, because every device is getting their data directly. It is not like ring topology, like every device get the data and forward it to next device. And in like no, not like a bus topology where everyone gets the data. If it is for one, it will get everyone will get it. So the privacy and security is not there. Now the problem for the mesh topology is installation and configuration is difficult. As you can see the image, how much wires are there for only these 6 devices? Too many wires are there, not easy for configuration and installing. Cabling cost is more than any other topology. Bulk wiring is required. Bulk wiring, that means as you can see the image, only 6 devices needs how many cables? You can see for one device you need 1 2 3 4 5 cables for only 6 devices. Now if I add one more device here, then I have to add that device with every other device, and it can increase the cables again. Like one device will get 1 2 3 4 5 6 cables to connect, and as I go on to add one more device, then it will get more and more and more cables, and very difficult to manage. So this is also not work in a LAN topology. In a LAN network also we can't use this star topology, this mesh topology. So finally we have what is star topology. Now the star topology uses a central controlling hub connecting all computers with the help of a twisted pair cable. So if you see central hub, you can see the image in a star topology where you see a single device, whether it is a switch or hub, it connects all the other devices directly. So it connects all the devices connect through the central device, which is hub in old days, and nowadays we use switch. And just like you can see in this token ring, why it was called star, you can see the central device where these other devices are connected like this. So it also called what? Physically it is a star, we can say, but logically it was working like a token ring. But this is what is star topology, where all the devices are connected to the central device through the twisted pair cable, and this is the topology which we use till now. Then each network devices has a dedicated point-to-point link to the central hub, and there is no direct link between these computers, and the computers can communicate via central controller only. That is what the hub or switch. This strategy prevents troublesome collusion and keeps the line of communication open and free of traffic. Now the routing function is performed by the central controller, which centrally controls communication between any two computers by establishing a logical path between them. Now remember, it controls the central device, that how these devices will connect, and what when you try to send the data from one device to other device, so this central device, the controller, do what? It creates a central it creates a separate logical path. Remember, physically they are not connected directly, but this device do what? It create a logical connection, direct connection with those devices. Now these devices don't know that they are connected with this hub or switch. Remember, your computer, your nodes, your machines don't know that there are some other device which is joining them together. They feel like they are connected together directly. That means this machine feels that it is connected directly to all these three or these all four machines. That means your machine, your computer, your node feels like it is connected in a star topology, a mesh topology, where all the devices are connected directly to this machine. But in reality, this machine is connected to this switch and hub, and this switch and hub is doing what? It is creating a separate logical line for them to do the communication. So it means that if one computer A wants to send data to another computer B, so computer A sends the data to the controller, and this controller then sends the data to a computer B. So the data will go to the switch hub, and then it will send it to other. And this topology obviously requires a great deal of cabling. So it also needs a big cabling also, and this design provides an excellent platform for reconfiguring and troubleshooting. And changes to the network are as simple as plugging another segment into the hub, and a break in the LAN is easy to isolate and doesn't affect the rest of the network. That means adding new devices and removing devices are not that difficult here. Like, it is just, you just plug or unplug the cable from this central controller, that is hub or switch. So here all the devices feel like they are connected together directly. So we can say logically it works like a mesh topology, but physically it is actually what? Star topology. But when it was using hub, then it was not work like a mesh topology, it was working like a bus topology. So it uses still the same technology which is worked on bus topology to avoid the collusion, and that is CSMA/CD. So we can say this star topology is actually the advanced version of bus topology. Now it also has advantages and also disadvantages. Advantages are like fast performance with few nodes and low network traffic. So it is also giving you the fast performance just like the mesh topology, but it is not a mesh topology, it is logical mesh. So it will not give that much speed, it will give you low network traffic, like when you are having low network traffic. Then hub can be upgrade easily. That means hub, that is the centralized device, we can upgrade it easily, we can change it easily, like changing from hub to switch or any other device. Then easy to troubleshoot, easy to set up and modify, we can easily configure it, we can easily troubleshoot it, then we can modify it easily. We just have to remove the cable or add the cable, and only that node is affected which has failed. Rest of the nodes can work smoothly. Now because it is using the CSMA/CD, so if the collusion is there, so the jam signal will go and affect the other machines. But in this, it will not affect the other machines, it will only affect the machine which is doing the collusion. So other machines can do and work their own. Now the disadvantage for the topology, is cost of installation is high, because it is using lots of cables like mesh. Somehow it is like mesh, so it is expensive. And because it is using the centralized device, the extra device, so also it is expensive to use. If the hub fails, then the whole network is stopped, because all the nodes depends on the hub. So because all the network, all the devices depends on this centralized controller, whether it is hub or switch. So if it fails, then your network fails also. Then performance is based on the hub, and that is depend on its capacity, and also it depends on the capacity of the centralized controller, that how much speed you will get, because this device is the responsible for creating the logical circuit with these different devices, because physically they are not connected, and it can do it for multiple devices at the same time. That means this device is sending to this device is sending to this, and also this. So it creates the physiological direct connection. So it uses by using its processing power. So it depends on the performance and processing power of the controller, which is a hub or switch. So these are the little advantages, disadvantages. Now when we talk about hybrid topology, now hybrid, as a name suggests, hybrid like mixed with multiple topologies. So it is not like a real topology, it is a logical topology itself. It's not a physical one. We can say it's itself a logical one. Like hybrid topology is a type of topology that is composed of one or more interconnections of two or more network that are based upon different physical topologies. Like you are having bus here, you are having star, you are having ring, and you are connected all together. Then we can say that it is what, a multiple this is a hybrid topology, where we are having multiple different type of physical topologies working together. So when two hubs of different topologies are joined, so that the devices attached to them can communicate, and it is called a star bus network. Like this, when two or more star topologies are linked together using a specialized hub called MAU, like multi-utilized unit, access unit, so it is known as star ring topology. Now because they are different topologies, for connecting them you need a different type of technology, a different type of device, like this MAU, or you can use a star bus network. You can use with attaching the cable directly also, like this backbone cable to the switch, so it will connect with this other topologies also. Now you remember I said this topology, bus topology, can make a collision. So if the collision happens here, then it will not affect the star topology, because it does not forward the jam signal to other devices. It will remain on this single link only. That is the benefit of this star. Now what is the advantage of disadvantage of this hybrid? Reliable, as error detecting and troubleshooting is easy. Then effective, then scalable, as a size can be increased easily. Flexible, these are the advantages. Disadvantages of fault detection is difficult, because you are combining multiple different topologies, then it is difficult for you to find out the fault. Installation can also be difficult, because as you see you are combining multiple the topologies. Design is complex, so maintenance is high, thus expensive. So because of the design it is also expensive. Then you are having a tree topology. This is also kind of logical topology, where we combine the different physical ones, like it has a root node and all other nodes are connected to it, forming a hierarchy, and it is also called hierarchical topology. It should at least have three levels to the hierarchy. Like that means like you are having one centralized device, and we can say it is what is star topology, but it is arranged in a tree way. In a way it is hierarchical. like you are having one central, then these are connected to two different, then these are connected to these different devices, like this. As you can see the image, it looks like it is tree upside down, where you have root and you have branches. So we can call it as a tree topology, but basically if you see, it is a three different star topologies which is connected to a single hub. What is the advantages? So advantages of extension of bus and star topology: it is an expansion of nodes is possible and easily managed and maintained. Error detection is easily done. Disadvantage of three topology is heavily cabled, lots of cables, costly. If more nodes are added, maintenance is difficult, and central hub fails, then network fails. Central hub, that means these central hubs fail, then your network will not be connect. These machines will not able to connect to other machine, other star topologies. Now this is the CSMS/CD which is used in bus topology. Now because we are not using the bus topology now, we are using the star topology, but still the star topology is advanced topology of the bus, and still in a star topology we use this CSMS/CD. So you should know this basic thing about this CSMS/CD also. Okay, so this we will see tomorrow, and then rest of the topic also.